Yes, students, hope you are well. In last video, I have explained your science chapter, that is chapter 9, force and law of motion. In last video, I explained different terms related with that chapter and Newton's first law and second law. Now in this video, that means in this class, I shall explain Newton's third law of motion, its various examples and conservation of momentum. And so let me discuss Newton's third law of motion. The statement of law is, according to this law, to every action there is an equal and opposite reaction. Let me first explain what is action and what is reaction. Let me take take two objects, suppose A and B. They are moving. Suppose body A gives a force to body B, then we call it action. So automatically body B also gives force to force A, body A. So this is reaction. So according to this law, every action there is an equal and opposite reaction. Let me explain this law with a simple example. See, while walking, we press ground with our feet in the background. That is which we are applying day-to-day life. While walking, we press ground with our feet. That means we are giving force to the ground with our feet. Okay, so this is action. Automatically, the ground also exerts equal and opposite force to our feet. That is reaction. Due to that, we are able to walk. So this is a very simple example of Newton's third law of motion. Now let me discuss the Newton's third law of motion and its application. You see, the Newton's third law is applied in law of conservation of momentum. You see, law of conservation of momentum says that if a number of bodies interacting with each other, that is exerting force on each other, their total momentum remains conserved before and after interaction. Remains conserved means before collision and after collision, total momentum remains same. So their total momentum remains conserved before and after interaction, provided there is no external force acting on them. We must understand that there is no external force acting on the bodies. Now let me explain in details in the next slide. And so you see in this slide, it is written direction of law of conservation of momentum from Newton's third law of motion. Let us take two objects, object A and object B. Okay, the mass of object A is ma and mass of object B is ub. They are both moving in the same direction. Okay, you see velocity of body A is more than the velocity of B. So it is written UA is velocity of body A and UB is the velocity of body B. So automatically after some time the body A will collide with the body B. Okay. So when they collide, according to the Newton's third law of motion, body A exerts and force FAB to the body B. Okay. At the same time, body B exerts equal and opposite force to body A. So when body A exerts a force on body B, we'll represent it with FAB. Again, body B exerts equal and opposite force to body A, which is represented by FBA. So after collision, you see both the bodies will move with different velocities. Mass will remain same, mass A and MA and MB, but body A and body B will move in the same direction with different velocities, that is VA and that is VB. Let's see the mathematical deduction. So see, let us consider two bodies A and B. You have seen in the last slide of masses Ma and Mb moving in the same direction along a straight line with different velocities UA and UV respectively, such that UA is greater than UB. In the last slide, I already explained that velocity of object A is more than the velocity of object B. So UA is greater than UB. They collide for some time T. After collision, let their velocities become VA and VB. So force exerted by A on B is FAB. The F in the Newton's second law, we have deducted that F is equal to M into A. So what is A? V minus U by T. So FAB, that means force exerted by body A to body B. So is equal to rate of change of momentum of A is equal to MA, and what is the acceleration? VA minus UA divided by T. That means velocity of the body A will change from UA to VA in time T. So this is the acceleration. So we know that force is equal to mass into acceleration. So FAB is equal to MA into within bracket VA minus UA by T. So by Newton's third law, body B also exert an equal and opposite force to body A. So it is given by FBA. So FBA is equal to rate of change of momentum of B. So MB VB minus UB divided by T. UB is the initial velocity of the body B. After collision, final velocity of the body B will be VB and mass will remain same. So it is the rate of change of momentum. So according to the Newton's third law, action is equal to minus reaction. Minus what? What do you mean by minus? Why we put here minus here? Because action and reaction are direction of action and reaction are opposite to each other. So or we can write FAB is equal to minus FBA. So we'll put the values FAB from here. MA within bracket VA minus UA by T is equal to minus what is FAB from here? MB within bracket VB minus UB divided by T. So in the next step, you see on the left hand side and right hand side, a denominator same TT. So we can cancel T. After cancelling T and open the bracket, MA VA minus MA UA is equal to minus MB VB minus minus plus MB plus UB. Now we'll shift we'll transpose MA here in the third line, MA VA plus MB VB minus MB VB from right hand side to transpose to left hand side, it will be plus MB VB, and MA UA, it is minus here on the left hand side. So if we transpose to the right hand side, it will be plus MA UA plus MB VB. So in the last step, we have interchange left hand right hand side. So MA UA plus MB UB is equal to MA VA plus MB VB. On the left hand side, it is the total momentum before collision. On the right hand side, it is total momentum after collision. So thus, it is proved that total momentum before collision and total momentum after collision remains same. This came from Newton's third law of motion. So students, I think you understood the law of conservation momentum and third law. Thus we finished this chapter. Thank you, students.